All right. Let's go through. So what we're doing today is composition of functions. But yesterday we were doing operations on functions. Today is composition of functions. And all that means is instead of adding them together or subtracting them together, we're going to put one inside the other. So when it says with this little dot, our open circle, this means we're going to take our f function and we're going to substitute g of x in place of the x. F of g of x. Like the second one is g of f of x.
These are fun. Well, as fun as math gets.
I'll take it. So we don't have to use a different function each time. Down here it's saying f of x. We can plug the equation into itself. Same thing with g of x. And I prefer this notation just because I feel like it's clearer. I feel like it's much clearer if we stack our parentheses like that. But if you like the circle, totally fine. They mean the exact same thing.
Wasn't there like some fancy, you were supposed to put like a different kind of parentheses somewhere? So it wasn't like parentheses on parentheses. I don't remember.
You can use brackets for that
Oh, okay.
if it helps you.
Oh, yes, my mom uses those all the time. That you're talking within a parentheses within a parentheses.
Yeah.
You use brackets, you're so right.
Yeah, you can use brackets.
Like in English. Yeah. Yes. I don't know about math, but.
You can. It's totally fine to use them. It's totally fine to use brackets if the multiple sets of parentheses bother you. You can use them as brackets. But you also don't have to. Parentheses upon parentheses upon parentheses is still fine. It's just counting. Just count how many you got. All right? And that's what we're going to do with them. We're going to be working with this all day. It's composition of functions. So we're going to do f of g, g of f of f, and g of g. With these two functions, we've got f of x equals 2x minus 1, and g of x is negative x squared. And I'm going to do my f of x in blue and my g of x in green because I like to color code things. It makes my little ADD brain happy. So our first one we're going to do is we're going to do f of g of x. That's this guy here. This one's number 1. Boop, 1. They mean the same thing. F circle G is the same thing as f of G. So what we're going to do is we're going to take our f function, which is 2 times something minus 1, and in place of that x, we are going to substitute our g of x, minus x squared, minus 1. And then we're going to simplify this. How can I simplify this? Yeah, it feels like distributing. But there's not any adding inside. So what are we going to have? Just multiply them, right?
Negative 2x squared minus 1.
Ta-da! Yes, dear. Because that is our g of x function. This guy up here. So then we're going to go the other direction. Number 2 up here is g of f. So So I'm going to do number 2. So this time g is going to be on the outside, and we're going to put f of x inside. So my g of x function is the opposite of something squared, but that something is going to be our 2x minus 1. So what are we going to do first to simplify this? Square it. Order of operations says we do our exponents before we deal with that minus sign up front, because the minus sign is multiplied. So we're going to have the opposite of, what is 2x minus 1 squared?
4x squared minus 4x plus 1.
4x squared minus 4x plus 1. 2x minus 1 times 2x minus 1. 4x squared minus 2x twice. Negative 1 times negative 1. Now we need to distribute that negative sign. So our answer here for g of f of x is negative 4x squared plus 4x minus 1. Our simplified answers are not going to have any parentheses in them. So that's our answer here. This is our answer here. Just trying to make it clear because I know it's starting to get smushy up here. Questions on either of these two? It's the exact same vibe for the other two. We're just going to take f of x. So we're going to take f of x and substitute it inside of itself. Let's do number 3. Oh, I've been using the chunky pen. No wonder it felt chunky. So we're going to do f of, and then I'm going to do purple for the second round. F of x. And we're going to substitute f of x inside of itself. So we're going to have 2 times something minus 1, but the something is 2x minus 1. Because we're taking our f of x, 2 times something minus 1, and we're going to put f of x inside the x. So we're stacking it inside of itself. And I know my blue and purple are awfully close together up here. So what are we going to do to simplify this? Distribute. So we're going to have 4x minus 2 minus 1. So our answer for f of x?
4x
minus 3. Okay, so the ones where you're doing the function upon itself is the weirdest ones. They feel real weird. Let's do number 4 and we'll try this again.
Can you do it like multiple times? Like,
Yes.
Like f of f of f of f of f.
Uh-huh.
That.
Yes, you can. And in fact, in calculus, you will.
Okay.
And you can do composition of functions on all kinds of weird functions. In fact, that's what I'm doing this week in my college class. Composition of matrices. Yes, dear.
Is the next one gonna be like this one too?
Yes.
So is -1 gonna be the outside and a squared gonna be on the inside?
Yes. Because we're doing number 4 here. This is g of x. So I'll put my green g of, and I'll do purple again, g of x. So we're substituting g of x in place of the x. So my g of x function is the opposite of something squared. And we're substituting in g of x as place of that something. Minus x squared. This is the something we're substituting in. I'm going to take the circle away because we don't like that. And then we're going to simplify this. What is negative x squared squared? X to the fourth. That negative sign is going to cancel out. So we're left with a negative on the outside. This is that green minus sign. X to the fourth. Because negative x squared times negative x squared gives you positive x to the fourth. Because this minus sign is still on the outside. We have to do our exponent first. Negative x squared times negative x squared gives us positive x to the fourth. So that's the parentheses part. And we still have this minus sign out front. So we still wind up with minus x to the fourth when we drop those parentheses. And that's our simplified answer. So doing these compositions upon themselves is the trickiest part. It's doing the exact same thing as f of g of x and g of f of x. It just feels weirder because we're doing f of f or g of g or h of h or h of g of f. Okay, we're going to practice this again. I promise. You guys ready for the page to turn? Okay. Because sometimes we are not just asked to find of x. Here we have f of g of negative 2 and g of f of 3. And you could absolutely go f of g of x and then plug in, but that's the hard way. So I'm going to do my f in blue. I'll do my g in green. Because what we're being asked of first is f of g of 2. Oh, negative 2, excuse me. Like this, right? What is g of negative 2? So we're going to take 3 times negative 2 plus 4, right? So we could substitute it in. Negative 6 plus 4. Or negative 2. So we're really asking what is f of this negative 2. So when we give you values, you don't have to compose the whole functions. You can compose the solution. And it's actually significantly less work. Because what is f of negative 2? 2 times negative 2 minus 5. So f of g of negative 2 equals negative 9. And we didn't have to compose the functions. We could. They're both linear functions. We could do it, but it's a lot more work. So you can just compose the numbers when they're giving us numbers. And we're going to try that again the other direction with our second one. I'm going to give us a little barrier here so we don't blend them together because I'm using the same colors. Because our next one, we're going to do g of f of 3. So I'm going to start with finding f of 3. So f of 3 we find by taking our f and substituting in that 3 in place of the x. What is f of 3? Because we have 2 times 3 gives us 6, minus 5 gives us 1. So when we say g of f of 3, what we're really saying is g of 1. Because f of 3 equals 1. What's g of 1? 7. So g of f of 3 equals 7. Those are our two answers here. Not too gross.
Yeah.
I love the skepticism on that. Yes, dear. We took our, since I know f of 3 equals 1, we're doing g of 1. So if we substitute in 1, 3 times 1 plus 4. Okay? Ready? Or need a second? I didn't hear any objections. So let's try it with a slightly grosser one. But again, it's f of g of negative 2 and g of f of 3. So it's the exact same process as the last one. Oh, that's not the one I wanted. This one. So we're going to have our blue and our green. Because I find the color coding incredibly helpful on this. So we're going to do f of g of negative 2. So the first thing I need to know is what is g of negative 2? So we're going to take 2 and substitute in our negative 2 in place of the x. So g of negative 2 actually equals what? Negative 5. Since g of 2 equals negative 5, what we're really asking is what is f of negative 5? So now we're going to go to our f function and substitute in negative 5. 2 times negative 5 squared plus 3 times negative 5 minus 4. This one's a bit longer. So we can do it in pieces. 2 times negative 5 squared. 50. Plus 3 times negative 5 minus 15 minus 4. So what is our total for f of g of negative 2? 31. Okay, same process, but the other direction with g of f of 3. I'm going to give us a little barrier again, just so I have some space. So we're going to take g of f of 3. And we're going to work from the inside out. So first I want to know what is f of 3. So we're going to take our 2 and substitute in 3 squared plus 3 times 3 minus 4. So we're substituting in that 3. So f of 3 equals 2 times 3 squared gives us 18 plus 9 minus 4. So what does f of 3 equal? 23. So we're going to take the fact that f of 3 equals 23 and we are going to substitute that in place of our g. We're going to have 2 times 23 minus 1. Bring this down over here. So 2 times 23? 46 minus 1? 45. So g of f of 3 equals 45. Okay, so that's what that equals. How we feeling on that part? Okie dokie. So we've gotten the composition kind of under our feet. Dealt with kind of remembering what that is. Let's do some compositions. These are the kind that are kind of on the homework, okay? So they're going to have funky functions. They're not just going to be linear functions. So we're going to do f of g of x. So we're keeping the x. And then we're going to find the domain. So again, I'm going to color code stuff because I find that very helpful. So I'm going to do f of x in blue, g of x in green. And we are doing f of g of x. So in place of the x in the f of x, we are substituting in, it's very much like substitution, our g of x. So we're going to have our square root of x plus 2 squared minus 3. I'll erase that blue squiggle right there. We're going to put this in place of the x here. It's substitution, just using a function rule. What happens when we come in to simplify? The square root and the square cancel out. And we're left with just x plus 2 minus 3. So our function rule is x minus 1. Now we're going to find our domain, which means I need to look at my domains of my two composing functions. What is my domain for f of x? What is the domain of an x squared? All real numbers. So from negative infinity to positive infinity. How about on my g of x? What's our domain?
Everything except negative.
You're on the right track, but it's not everything except -2.
You're
Negative 2 and bigger. Because we're not having imaginary numbers. We're living in the world of real numbers. So it needs to be negative 2 or bigger so that it's 0 or bigger under the radical. So from negative 2 to infinity. Our composed function cannot be bigger than our domains of our composing functions. Yes, dear. Because I can have it equal 0 underneath. We can take the square root of 0, it's just 0. I just can't have anything negative. So, since my domain of my composed function can't be bigger than the pieces I used to build it, the domain of f of g of x is going to be from negative 2 to infinity. Because the domain of them smashed together cannot be bigger than these guys were to begin with. Okay? We have 2 more like this and then we're done. We're doing good. We're doing good. Okay? So we have time if you guys have questions on stuff. If we get stuck, let me know. Let me know. So we're going to do another one in this fractiony. So we're going to, again, do f of g of x and find the domain. F of x is x over x minus 2. And g of x is 3 over x. So we've got a couple of rational functions here. So again, I'm going to do my f of x in blue and my g of x in green. Since we're doing f of g of x, f of g of x, I'm going to substitute g of x in place of both x's. And it's going to look real gross for a hot minute. Because my numerator is 3 over x. And my denominator is 3 over x minus 2. So first thing I need to do is I need to fix that denominator so it's just a single fraction. So they need to have a common denominator. What can we do to fix this guy with a common denominator? What do I need to multiply the 2 by? X over x. To get to a common denominator of x. So our denominator is going to be 3 minus 2x over x, right? So we have our whole function over here. I'm going to write it again. We have 3 over x, big over 3 minus 2x over x. When we divide by a fraction, what is the way easier way to do that? Multiply by reciprocal. So what we really have here is 3 over x times, flip the bottom to be x over 3 minus 2x. What happens when we multiply these?
3x over, or
The x's cancel. So we get 3 over 3 minus 2x. Can I cancel out those 3's? No. I had a lot of people cancel things like that on the last stuff that we were looking at. If there's adding or subtracting, I can't cancel it. So we have f of g of x equals 3 over 3 minus 2x. And that's our function rule. I'm going to erase this highlight and redo it down here. Questions on the function rule part? Because now we're going to look at our domain. What is our domain for f of x? Or what can't it be for f of x? X cannot equal 2 because we can't divide by 0. How about for g of x?
0.
X cannot equal 0 because we cannot divide by 0. So look at our new function rule. What can't our denominator be here? Yeah. So we're having a new rule on here. I still can't divide by 0.
Yeah.
So x cannot be 3 halves here. Or 2 or 0. So if we get to write it like this, we love that. We love that for us. Sometimes we're going to have to write it in interval notation, and I'm going to give us a little bit of space to the right so that we can write it in interval notation, and I'm going to make it so y'all can see it. So in interval notation, I'm going to put this 0 now in the same line so it makes sense. So we can go from negative infinity to what? What's our 0? Our smallest is 0. Parentheses. Union. What's our, from 0 to, what's our next smallest? 3 halves. Union. 3 halves to 2. Union 2 to infinity. So this is our interval notation. This is our holy cow way easier algebraic notation. It's all real numbers except x can't equal 3 halves or 2 or 0. So this would be algebraic. Okay, so I wanted us to practice that interval notation so that we can see it. I believe there is one on the homework where it's looking at tables, I think. So I want us to see the tables thingy. And it is 100% evaluating. So f of g of 6. We've got f of x here. And I've got g of x here. And we are going to use it the exactly same way we've done before. F of g of 6. So we're going to look in the table. We're going to say, what is g of 6? So if x is 6, g is 8. Right? What is f of 8? F of 8 is 5. So f of g of 6 is 5. Okay, so the tables look super complicated, but I promise you they're actually super duper easy. Okay, they just look like a lot because it's a lot of information given to you right off the bat. So let's do another one, and I'll pick different colors so that we can keep that one up there. So let's do orange and black. So let's do G, ooh, that's not a pen. G of f of 6. What is f of 6? 7. So we're really looking at what is g of 7? 6. So g of f of 6 is 6. And I'm running out of space because I wrote this in a really big font. So let's do this g of 6 so that I don't run out of space here. So g of 6. What is g of 6? 8. So g of 8 is 5. Okay? Because we had our g of 6 gave us 8. That was this guy. And then g of 8 gave us 5. That was this guy. Okay? So the table 1 looks super complicated, but it's just match them up. Inputs to outputs. Okay? End of Unit 3. Or Unit 2, Chapter 3. Sorry. I'm going to give you the review. Right. Slide before this. That one? All right, I'll zoom in. Oh, sorry, I'm making it so it's all there. Okay. I will also post the PDF today. So I'm passing out the review. The YouTube videos for every single question are in the process of being uploaded right now. However, I learned yesterday that YouTube will only let you upload 10 videos a day. So when I did a separate video for every single question on the review, it got real grumpy at me. So they will get posted. Half of them are up right now, but the other half are waiting for the day to reset, which I think is going to happen at 4 o'clock this afternoon when the rest will upload for us. Because I am not going to be here tomorrow. I'm out on another training tomorrow. And then we're virtual on Thursday. It is virtual school on Thursday. It is not synchronous, so there's not videos. These are parenting conferences. But the videos for literally every single question on this are currently in the process of being uploaded, which means the answer key will be uploaded during 5th period today. They're there. The answer keys for all the homework will be uploaded during 5th period today. I have a couple behind. They'll get it, and I'll get all the grades in today. Okay? So that we know where we're sitting before we get to the quiz on Friday, or test on Friday. Okay? As you're working through stuff, even tomorrow, I will have my email with me. You can send me emails, you can text the text line, whatever you need. I can always send you videos or YouTube videos that'll be helpful. Okay? So let me know. I'm happy to help you. Absolutely thrilled to help you. Okay? So let me know how I can help you. That's the only thing, is I can't read your minds. Okay? So we have 2 minutes to the end of the period. So there's the homework page with the numbers for 3-7, which you should already have. But y'all get grumpy if I don't post that picture, if I don't put that page up. Mostly because I'm not really organized enough to not do it. It's just not going to help you get ready for the test with this handicap yourself. What's up? Say it again.
I remember what was it about, but I'm
not sure because it was like so long.
Yep, I will be pulling it out of the file folder and going. I don't remember what
So can I take like because I also have quiz 5, so I don't know when I can take.
You could come. You could come on Friday. Yeah, or you can do it after break. Like it's totally fine. Okay.
What's in quiz 3?
I don't remember. Quiz 3 is rational functions, and the sections 2-1 to 2-3. Yeah, 2-1, 2-2, 2-3. So that'll give you things to look at.